Hi, this is Dr. Perry Carpenter. I'd like to thank you for taking the time to join me on today's video. Today's video, I have some special information for you regarding spinal impairments and the analysis of motion segment integrity. And this material is extracted from Chapter 15 and is paraphrased from a 6-hour QME continuing education program that I previously published, entitled The 21 Secrets of the Most Persuasive QMEs. And it seems that the most persuasive QMEs in the entire state have several procedures that they commonly employ, or I should say that they employ in common. And one of those is the analysis of motion segment integrity procedure. Now, some doctors admit that they do not do an analysis of motion segment integrity on their spinal cases. And when I ask them, why not? Why don't you do an analysis of motion segment integrity? The doctors will tell me that they have yet to fully systematize the process of, number one, ordering the necessary diagnostic studies, and then number two, sitting down at their desktop and taking the flexion and extension radiographs and making the necessary measurements and then reporting their findings in a credible and substantial way into their QME reports. And they simply have not taken the time to systematize this procedure. And I can empathize with that because if you don't do a lot of spinal cases, or you don't do a lot of QME examinations in general, establishing these procedures for the first time through can be cumbersome and time consuming. Well, I want you to know that I've already done it for you. So you can forget about having to reinvent the wheel. I've already done it for you. I've done hundreds and hundreds of motion segment integrity analyses, and I have the procedure completely systematized, and I want to share that procedure with you today. And then at the end, I want to make it easy for you to adopt this procedure into your own protocol and procedure by providing you with the necessary templates if you don't already have those established. So we're going to be talking about the analysis of motion segment integrity, and this is found on pages 378 and 379 of the AMA guides. So let's take a look at what the AMA guides see what they say about motion segment integrity, and then we'll get into some actual measurements on actual x-rays of bona fide examinee. Okay, so here we are on the AMA guides in chapter 15, and we're on page 378 here. And the first mention of motion segment integrity is here at the bottom of page 378. And the AMA guides first begin by defining what actually constitutes a motion segment. So they say that a motion segment of the spine is defined as two adjacent vertebrae, the intervertebral disc, the apophyseal or facet joints, and the ligamentous structures between the two vertebrae. And then the AMA guides go on to tell us what they consider to be normal angular motions throughout the extreme of flexion all the way through to the extreme of extension in the cervical spine in the thoracic spine, in the mid-thoracic spine, and then also in the lumbar spine. So they give us here what they consider to be the normal ranges. In the lumbar spine, we see about 12 degrees of total angular motion at L1 to L2, increasing to 20 degrees total angular motion by the time we get down to the L5 to S1 level. And then on page 379, the guides show us how to do these measurements. So let me point out a couple of distinctions here. In the lumbar spine, we use the superior end plates. We draw a line across the superior end plate of one vertebra, the superior end plate of the vertebra below. We measure our angle, and you'll notice that this would be the flexion angular measurement. Flexion angular measurements are positive measurements when our angular lines converge anteriorly. Notice that these lines are converging anteriorly. They're diverging posteriorly. Normally, in a normal lumbar lordosis, the angles diverge posteriorly. The lines diverge posteriorly. Here in extension, you see we have the lines converging now posteriorly. Those give us negative angles. So in general, flexion angles are positive angles, but you need to track your positive and negative signs very carefully, because not always are flexion angle measurements positive, especially when we're in the lower lumbar levels. It may be that L4 and L5 fail to reverse the lumbar lordosis, and they remain in a negative angle. So you need to track your angles very carefully. In the cervical spine, we don't use the superior end plates, but here we use the inferior end plates to make our angular measurements. And the distinction is in the cervical spine, because of the C2 vertebra and the odontoid process, we do not have a superior end plate on the C2 vertebra. So we're going to focus on the lumbar spine, and we're going to draw some lines and angles on some actual x-rays from a bona fide and actual examinee. And we're going to come up with our measurements, and we're going to make our decisions together as to whether or not our measurements constitute an alteration of motion segment integrity. And the way we're going to do that is we're going to compare our measurements against what the AMA guides describe right here to be normal total angular motion measurements throughout the lumbar spine. So let's now demonstrate these findings on some actual x-rays. Okay, so here you see we have the images, and this is I believe this is an 8-view lumbar spine series. Yeah, up here we see that these oblique views are duplicated. This is the left oblique, and this is the right oblique, and those are duplicated. So this is a 1, 2, 3, 4, 5, 6, 7, 8-view lumbar spine series. And this is the routine series for the lumbar spine. Includes an AP. Here's an AP with a 15-degree cephalad tube tilt. Here is your lateral lumbar. Here is the left and right obliques, and lumbar extension, lumbar flexion, and L5, S1 spot shots. So let's just take a look at some of the findings on these studies before we do the analysis of motion segment integrity. So here's the AP image. This is labeled here with the right side. This is the right side of the examinee's body. So you'll notice that something looks a little bit unusual down here. And these are some post-surgical changes following L5 laminotomy, medial facetectomy, and foraminotomy. And you can see that there's some sort of a post-surgical defect right here and through here. In fact, if we magnify that a bit, probably become even more obvious. Yeah, so there's some sort of a defect here, laminotomy defect. Looks like perhaps a spina bifida defect of the S1 spinous process or the posterior elements of S1. Anyway, so that's our AP view. Our lateral view is located right here. And I point out the lateral view to show you that it's possible that there may be some form of lumbosacral transitional vertebra here. I don't know about you, but perhaps you might be able to hallucinate a vestigial disc or some sort of segmentation of this S1 vertebra here from the S2 vertebra. So some suspicion for perhaps a lumbosacral transitional vertebra. So that's going to make our analysis of motion segment integrity interesting. So let's begin with that right now. This is our lumbar flexion view, and let's rotate that around so it's a little easier to manipulate. So in order to do our analysis of motion segment integrity, you're going to need a small post-it note. And I want you to go ahead and label your post-it note with each of the motion segments of the lumbar spine. And we'll just go ahead and fill in our findings on the angular motions. So let's begin up here at L1. If we consider this to be the L5 vertebra, that's L4, L3, L1, and L2. And we go up here and we locate our measuring tool, our angle measuring tool, and we click it. And we draw a line across the superior end plate here of L1, drawing our best fit line across the superior end plate. We then repeat the procedure across the superior end plate of L2, and the software measures the angle. So that's a 3.9 degree positional flexion angle. That's a positive angle between L1 and L2. Okay, let's just move that out of the way. It's L1, L2. Now we do the same thing at L2, L3. So there's 4, 3, 2. We're going to draw a line across the superior end plate of L2. And then across the superior end plate of L3 for an angle of positive 2.0 degrees. Move that out of the way. Then across L3 and L4 for 2.0 degrees, positive degrees. And positive degrees have diverging lines. The lines diverge posteriorly. Notice that these two lines are diverging posteriorly. They will never meet back here because they're getting farther and farther apart. They're converging anteriorly. So these are positive angles. When the lines back here converge posteriorly, then those would be negative angles. And I have a feeling that our next two lines are probably going to be negative lordosis angles. So let's move that out of the way. Now let's draw one across superior end plate of L4 and L5. For minus 8.1 degrees. And notice that that's a minus angle because these lines here are converging posteriorly. They're going to somewhere connect back here. Okay, and we could measure that angle if we had enough screen space to go back to a point at which those two lines meet posteriorly. So that's L1, L2, that's L2, L3, L3, L4, L4, L5. And then L5S1 would be right about here. And I can't really see that disk space very well. One thing that we can do is we can invert the image to see better if we have this disk space proper here. And it's just difficult to visualize. So I'm going to go with that at minus 13.9 degrees just for the purposes of keeping this moving along. Now let's go to our extension view and repeat the same measurements. And let's make this a little bit larger. Okay. 5, 4, 3, 2, 1. So let's begin at L1. Draw a line across the superior end plate. Same thing at L2. And I like these tools because they're so precise. They're so pinpoint precise. Now notice that this is a negative 9.6 degree angle. On our flexion angle, we had an angle of positive 3.9. So when we move from positive 3.9 to negative 9.6, well, that's a movement of approximately 13 degrees through which that vertebra has moved. And we'll demonstrate how to report our findings in just a moment. Okay, so let's delete that. Get that out of the way. Let's find out where we're at. There's L5, 4, 3, 2. Let's now do L2 and L3. For minus 9.1 degrees. Do L3, L4. For minus 14.6 degrees. L4, L5. For minus 25.2 degrees. And then finally, L5S1 probably somewhere through there, hard to tell, but I'm going to come up with minus 21.6 degrees. Okay, so we have our measurements, and let's now find out how we report those findings into the text of our QME reports. So then we go into our QME reports here, and I've brought up here my QME report template, and we're in the section of the report entitled Diagnostic Studies. So let me just say a couple of words about how to report the findings of your diagnostic studies. First of all, you want to report the findings of your studies as those are described by the medical radiologist. So give the reader a little bit of context as to what's happening. And I usually start with a script that says something like this. In order to obtain Mr. Jones's current condition, I referred him to a local imaging facility for updated X-rays of the lumbar spine. On February 10th, I received the results of those studies. The report of findings of those studies, as described by Jones, MD, of Modesto Imaging, included, and then here, write down word for word exactly what the findings and exactly what the impressions of Jones, MD, of Modesto Imaging were. Then what I want you to do is I want you to go ahead and provide your own interpretation of those studies. And now do not simply rely on the interpretation of the radiologist at the imaging facility. You are to provide your own interpretation of the studies as well. Remember that the medical radiologist serves as a consultant in this case, and it's okay if you agree 100% with the findings of the medical radiologist. If that is the case, then simply state that under a section involved or relating to your own interpretation of those studies. Okay, you never want to go to deposition and have any of the parties ask you, well, doctor, did you review the studies yourself? You want to review the studies yourself, and you want to be fluent and familiar with your own interpretation of those studies. So in this particular case, we're involved with the lumbar spine, so we'll delete these from our template. And here I want you to report the findings of your studies view by view by view by view, and give your description of your findings of each of the views in the study. Now notice here with the lumbar flexion and extension views, here's where I make a reference to the analysis of motion segment integrity table below that we're going to fill in just a moment. So here in my template, I indicate that spinal intersegmental relationships are intact and there's no evidence of ligamentous laxity. Of course, that text would change if there was actually some indication of alteration of motion segment integrity. Okay, so you put in your own findings right here, and make sure you do a beautiful job on reporting your findings. Then we go down to our motion segment integrity tables, and these are all included in your template. So here's the cervical spine table, here's the thoracic spine table, and here's the lumbar spine table. So let's work on the lumbar spine table. Well, we have our measurements that we just obtained, and so let's fill those in here right now. So do you have your little post-it note? I have my little post-it note, and looks like we're going through a period of Microsoft Word not responding. Oh, there we go. And here we have our flexion angular motion in degrees. Here we have our extension angular motion in degrees. Here we're going to do our calculation of the total angular motion. And then in this column of the table, we're going to make a decision as to whether the motion segment integrity is normal, whether it's increased, or whether it's decreased motion segment integrity. So let's go through our table and just make our decisions here. At L1, L2, we found that on the flexion radiograph, we had an intersegmental angle of 3.9 degrees with a positive sign. On the extension angular motion measurement, we had a measurement of minus 9.6 degrees. So let's do the math. 3.9 minus 9.6 equals 13.5 degrees. There's the L1, L2 motion segment goes through 13.5 degrees of motion from the extreme of flexion to the extreme of extension. Now, according to the AMA guides, in the lumbar spine, there is a gradual increase in flexion extension movement from about 12 degrees at L1, L2, about 12 degrees at L1, L2. Look at that, about 12 degrees. Well, we came up with 13.5, so I'm going to go ahead and say that that looks to be like pretty much normal. Okay? All right, what about L1, L2? Let's see what we get there. L1, L2, we had an angle of plus 2.0 degrees on flexion, and in extension we had minus 9.1 degrees. Let's do the math. 2 minus 9.1 equals 11.2. And it says at about L1, L2, we have about 12 degrees with increasing angular motion the further we go down the spine, approaching about 20 degrees at L5 to S1. So ordinarily, we would expect the L2, L3 motion segment to have a little bit more motion than does the L1, L2 segment. But with our crude measuring methods and margins of error, I'm going to say that 11.2 is roughly within normal limits for what we would expect in this area. In other words, it says we should expect about 12 to maybe 14 degrees if we increase perhaps 2 degrees at each segment to arrive finally at 20 degrees at the L5S1 segment. So here we should be somewhere between 12 and 14 degrees, and we're at 11.2. And so with our margins of error and crude measuring, I'm just going to go out on a limb, and I'm going to say that that's sort of roughly within what I would consider to be normal limits. If it's not normal, it's certainly not terribly abnormal. Okay? What about L3, L4? Well, here we had a flexion measurement of positive 2.0 degrees. In extension, we had minus 14.6 degrees. If we do the math, 2 minus 14.6 equals 16.6 degrees. And I'm going to say that that's within normal limits. In fact, I would expect that this segment of the spine would have about 16 degrees of angular motion, increasing from 12 to 14 to 16 to 18 to 20 degrees, as it says here, 20 degrees at the L5 to S1 level. That's what it says according to the AMA guides, and so I conclude that that's roughly normal. At L4, L5, we have minus 8.1 degrees. Yeah, that's a minus sign. So this vertebra is in an extension lordotic position, even at the extreme of flexion. And then in extension, it moves to minus 25.2 degrees. So let's do the math. Minus 8.1 minus 25.2 equals, looks like about 17.1 degrees of motion of this vertebra from the extreme of flexion to the extreme of extension, and I consider that to be roughly within normal limits. Somewhere between, say, 16 and 20 degrees of angular motion would be considered roughly normal, and I consider it to be that. Finally, at L5S1, we began with minus 13.9 degrees. And remember, this was a segment of the spine that was difficult to visualize. And so our measurements here we have to take with a grain of salt. So minus 13.9 minus 21.6 equals 7.7. Am I right? 7.7 degrees. Now that one we might conclude has some decrease in intersegmental motion, because according to the AMA guides, we should see about 20 degrees of angular motion at L5S1. So if you conclude that indeed this is an area of decreased intersegmental motion, and in your opinion that finding correlates with the mechanism of injury and all the clinical findings, you could then conclude that that segment has an actual loss of motion segment integrity and could qualify for permanent impairment. And the permanent impairment opinion begins here with your angular measurements. Okay, so doctors, that's how we do an analysis of motion segment integrity. We have all of these, you should have all of these tables already set up in advance in your template. And so when it comes time to do the measurements, they're already there for you and ready to go. All you have to do is simply report your findings and make your calculations, and it's already set up for you. If you don't have this template, I have this template available for you on my website, and I'll show you how to locate that template on our very next slide. If you need this template, you can simply go to my website, which is ezqmeceu.com. Once you're there, click on the online store. That'll take you to all of our QME products, and all of our templates are located over here under the QME report templates. We also have our continuing education home study programs here. Here we have a compendium of permanent impairments. This is a library of hundreds and hundreds and hundreds of permanent impairment opinions that are separated and categorized by body part. So, for example, have hundreds of arguments of cervical spine impairments, hundreds of arguments for lower extremity impairments, lumbar spine impairments, upper extremity impairments, multiple impairments. These are hundreds of arguments of actual cases that I've collected over the years, and I've extracted the permanent impairment arguments and organized them. So if you want to see the range of possible permanent impairments that you could possibly provide for your examinee, it's already probably been done for you, including impairments under the strict application of the AMA guides, and also under Almarez-Guzman 2. So with regards to the templates, you can click the templates, and here we have many different types of templates, including the entire QME report template. Also, we have for you the analysis of motion segment integrity template, which let me just show you that product. This is a template that allows you to record your measurements on flexion and extension radiographs. All you have to do is input the numbers, and the template does the calculation for you to determine total angular motion of each spinal segment. Comes with an instruction sheet on how to quickly and easily do this digitally on your desktop, and this is available for $49.99. I highly recommend that you get this template. I've used this template successfully for hundreds of cases, and it's not necessary for you to reinvent the wheel. I've already done it for you, and it's available here to save you time, effort, and money. So doctors, I hope that helps you. And it's my opinion that the analysis of motion segment integrity procedure will really set your report apart from the hundreds and hundreds of other reports that simply omit to consider permanent impairments due to loss of motion segment integrity. And once you get the procedure established, it's actually quite simple. It simply involves, number one, ordering the necessary studies from the imaging facility. Number two, instructing the imaging facility on exactly what you need in order to get the images proper so that you can make the necessary measurements on those studies or on those images. And then number three is simply performing the analysis of motion segment integrity right on your desktop using your computer, mouse, and embedded tools in the image viewing software. And then finally, reporting your findings in a credible and substantial way into your QME report. And in this way, you can fully support your findings for permanent impairment due to alteration of motion segment integrity when and if it exists. And I actually enjoy doing the analysis of motion segment integrity. It's never something that I dread to do. I never consider it to be a hassle. It actually allows me to get an up-close look at the x-rays. It makes me stop and look carefully at the x-ray images. And many times I pick up findings that I might otherwise miss. And so I really enjoy the process, and I'm sure you will too once you do it 10, 15, or 20 times. So doctors, I hope that helps you today. If you have any questions about this, or if you need to obtain the template, you can either log on to our website, which is www.ezqmeceu.com, or of course you can always email me at any time, or if you prefer, I'd be happy to take your phone call at 800-676-8127. And for now, I'm looking forward to being with you on our next video. And I thank you for being with me today on today's video. And I just want you to know that I'm wishing you best of success in your career as a qualified medical evaluator. This is Dr. Perry Carpenter. I look forward to being with you soon. Have a great day.